Well, objective for today's lesson is to first of all be familiar with the contributions by different scientists to the classification of elements. We're going to understand and explain the key features of the periodic table, and then we're just going to describe some general characteristics of metals, non-metals, and the metalloids. Keywords for this lesson are as follows: periodic table, period, group, metal, non-metal, and metalloid. The development of the periodic table, part 1. So contributions to the classifications of elements. What we're going to look at here are the contributions that different scientists made in terms of discussing elements and placing them on a periodic table. So many scientists contributed to this periodic table, but we're going to look at 4 in particular. So we'll start with a guy called John Newland, and this is right back at the start when the periodic table was first invented. And what he did was arrange the atoms and elements in order of their increasing atomic mass. Now we know now the increasing atomic mass is everything that is contained within the nucleus. What he noticed was that every 8th element there was a repeating pattern, and he named this the law of octaves. So the law of octaves describes the repeating pattern for every 8th element. Okay, the next scientist that got involved was someone called Lothar Meyer, and he found the connection between the atomic mass and the element's properties. And what he did was again organize the elements in order of their increasing atomic mass. So he didn't change the order of the periodic table, he just discovered there was a connection between that atomic mass and the element's properties. Moving on to the next scientist then, the third out of the 4 we're going to look at, he was called Dmitry Mendeleev. Now he was a Russian scientist, and he also ordered the elements in order of their increasing atomic mass. But what he did is he actually predicted properties of missing elements, and he left gaps in his periodic table that could be filled in when new elements were discovered which fitted these patterns that were being created. The final scientist was a guy called Henry Moseley, and he discovered that each atom contained a unique number of protons, calling this the atomic number, which we've looked at previously. Now what he was saying is each element had a unique number, it had its own number of protons, so what we could do is actually order them in their increasing atomic number, because each element had a different number of protons, but some of them had the same number of neutrons. So we now order the periodic table by increasing atomic number. And what you should see on your screen now is the periodic table. So this is the current periodic table, the periodic table that we use today. And what you'll see is it's ordered by their atomic number. Now each symbol here only contains its atomic number. I couldn't get one with both the atomic and mass number that was clear enough to show on the screen. So what you'll see is hydrogen has an atomic number of 1, then we go over to helium for 2, lithium 3, beryllium 4, boron 5, carbon 6, and so on. And this shows that the periodic table is ordered in increasing atomic number. Okay, so hydrogen has 1 proton, helium has 2, lithium 3, and so on. So we work from left to right in the rows, and we move down the periodic table. Now metals is one of the sections on the periodic table. So if we take this periodic table here, okay, what we'll see is the metals occupy the majority of the periodic table. So if we look, the whole section that is coloured in pink here is representing the metals. Now the metals we say would be on the left hand side and the middle of the periodic table, with an exception to this here, which is hydrogen. Okay, hydrogen is placed on the left because it is in group 1, however it is not classed as a metal. Now the metals are generally shiny, they're solid at room temperature, and they are good conductors. Okay, mercury is an exception to being solid at room temperature, that is actually a liquid, but the rest of them are solid at room temperature. If we think of things like gold, it's generally shiny, and gold is a very good conductor and is used in a lot of technology and things like mobile phones and computers. And finally, we say that metals are malleable and ductile. And what malleable means is that they can easily be bent into shape. So we use metals for many structures, and we're able to bend the metal into shapes, and it will stay in that shape in a solid position. And ductile means that it can be drawn out into thin wires. And as you hopefully know, we do use metals for many wires, so copper wiring is very common because copper is an excellent conductor. The non-metals. We said previously that the metals were located on the left-hand side in the middle of the periodic table, while the non-metals are located towards the right-hand side of the periodic table. And this is with the exception of hydrogen, which we said last time was not a metal, but is positioned on the left. So this is also classed as a non-metal, as well as everything you see here in blue. Okay. Now, these non-metals are generally gases. So the majority of them are gases. So we've got things like oxygen, nitrogen, chlorine, which are quite common gases. And then we also have some brittle, dull-looking solids that exist. Things like carbon is another good example. And the non-metals are the opposite to metals. They are poor conductors of heat and poor conductors of electricity. The last section we will look at are the metalloids. And you may have noticed the metalloids on the periodic table that I've been showing. So if we look here, we have 6 elements that are coloured in green. Okay, these 6 just here that bridge the gap between the metals on the left-hand side and the non-metals on the right-hand side. Now these elements here have properties of both metals and non-metals, which makes them very useful. Okay, and because of these properties, they're used in many things. Technology, silicon you may know is used to make glass. So they're used in many everyday objects that we use and devices that we use. Thank you for listening to the presentation. We will be discussing the periodic table in more detail in the following lessons.